Hello everyone. Today we're going to talk about central tendency and variability, which are very fundamental concepts for all kinds of statistics. And we'll talk a little bit about how we use those toward the end of how we sometimes have a hard time defining central tendency. The first one is a perfectly symmetrical distribution. It's real easy to see that the mean is 5. The median is 5. The most frequently occurring score, the mode, is also 5. But look at diagram B. It's a little bit different because it's very skewed one direction. And so the mean is going to be quite a bit lower than the median, and the mode is going to be an 8. So that's really quite a different shape of distribution. In diagram C, it's what we call bimodal. It's got two modes, 2 and 8, and the mean is 5, but the mean is a score that no one even scored at all. So we can have different measures of central tendency, and the mode, median, and mean are the three that we talk about. So mean, median, and mode, and this is pretty elementary stuff. You probably had it plenty in high school or even middle school, but let's talk about each one of those separately. The mean is the balance point, and we use the Greek letter mu when we're talking about a population mean. That's a Greek M, mu. And so think of the mean as being a balance point in the distribution. So that is kind of the definition of the mean. And of course, the way that we compute the mean is just the sum of all the scores divided by n. Now, if you have two means and you want to get a grand mean or a mean of both groups, you can't just average the two means together if the groups are of different sizes. So if you have, say, 6 people in one group and 7 in the other group, you have to total all the scores for the first group together, add the total scores for the second group, and then divide that by the number of people in group 1 plus the number of people in group 2, and that's what will give you your weighted means. There's an example in the book of this one that you can follow along with if you want to understand that a little bit better. Okay, let's think about some characteristics of the mean. Number 1, changing the value of any score changes the mean. And this is kind of a no-brainer because when you think about it, that's why you would like extra points on a test. You want your average to go up higher, so you want me to give you an extra 5 points on a test so that you know that changing the value of any score in a distribution will change the mean. So adding or removing a score changes the mean. So if I drop a test grade from your average, well, of course, that's going to make your average preferably higher if we drop your lowest test score. So adding or removing a score will always change the mean too. Adding or subtracting a constant from each score does the same to the mean. So if I added 5 points to everyone's score in the course, then it would also make the mean go up by 5. And we have a little illustration of that here when we have 6 rats here, and we have maybe a diet drug or something. So before drug consumption, maybe this was each rat's weight. And if each rat's weight goes down by 1 gram, from 6 to 4, 3 to 1, and so forth, then the mean is also going to go down from 4.33 to 2.33. So the mean went down by the same amount. Also, by the same token, multiplying or dividing each score by a constant also does the same to the mean. So, and here's the multiplication and division illustration. If we have our measurements in yards and we multiply by each person's score by 3 to convert that to feet instead of yards, so 10 yards becomes 30 feet, 9 yards becomes 27 feet, and so on, then your mean of 10 yards becomes a mean of 30 feet. Okay, the median is not used as frequently as the mean, but sometimes we use it, especially in a very skewed distribution. And a skewed one is one where most of the scores are at one end or the other. And so in this one, the mean is 4, but no one even scored a score of 4. So the median score is going to be the middle point in the distribution. And so sometimes the middle point in the distribution is a little bit more descriptive than the mean. The median just means that half the scores are above it and half the scores are below it. So the median in this case would be a 2.5 because two people made a 3, one person made a 12, and then 3 people made a 2. So between the third and the fourth score, halfway between the third and the fourth score would be the median. So that would be a score of 2.5. So that is a skewed distribution. The mode is just the most frequently occurring score, and it's usually not really used in descriptive statistics very much, except maybe just kind of as an extra freebie. So if you just need a little bit of extra information, you might tell what's the most frequently occurring score. Sometimes it's meaningless. And this one, we've got restaurants around campus, and we say that the most frequently occurring or the frequently attended restaurant is Luigi's at 42, and so you would just say the mode was 42. This one down here on the right, the box on the right, is talking about catching fish. I think the authors of our book are fishermen because they like these illustrations. And they're saying the number of fish caught is highest, and we all know that if you're a fisherman, you know that at dawn and dusk you're going to catch the most fish. So this one's bimodal. That means it has two modes, where the highest number of fish caught were at 6 a.m. and at 6 p.m. And of course the mean and the median are going to be somewhere in between there. So which do we use? Well, we usually use the mean because the mean gives us the most information. So the mean is typically what is reported. The median is used if, number one, we have extreme scores or a skewed distribution like the one that we looked at a while ago. Also, if we have undetermined values, and this box on the right shows that there are a lot of missing values here. We have scores of 10 to 13, and then we have several that are missing, and then we have the 100. And so that would be undetermined values or an open-ended distribution where there just seems to be no maximum. They just keep on going up or keep on going down. So the median could be used in those situations. The mode is only used if it's nominal data. Now, nominal data is just data that is not, we can't do a mean or a median with nominal data. So what's the average eye color in this room? We can't say that in our class. Even a class of just 8 to 10 people, we can't say what's the average eye color. We have to say what is the most common eye color because that is nominal data. It can't be averaged. So we can't find a mean or median to that. Also, just to describe the shape of the distribution, like describing it as bimodal, we might use the mode for that. And for discrete variables that cannot be divided any more than a whole number. It cannot be 2.5, it has to be either 2 or 3. So sometimes we use the mode in that situation. Now, central tendency can be graphed in many ways, and you do see the graphs. And in this one, you see the bottom graph you see is a histogram, and a histogram just shows the average cost of houses in the Northeast, South, Midwest, and West. Apparently, this graph did not include Nashville because the South would be much higher if it did. But that's the median cost of new houses. So that's just a histogram. A bar graph will have those spaces between the bars. If we're using nominal data where the categories are distinct, then you're going to have the spaces between the bars. So that is the difference in a histogram and a bar graph. Scales of measurement. So if you have nominal or ordinal data, you use the spaces between the bars, and if you use the bars right next to each other, that indicates interval or ratio data like we talked about before. Then we have a frequency polygon up at the top, which is another way to show central tendency. And so each one of these is just mean food consumption over the course of several different quantities of drug dosage. And then we have shape of distributions. So look at diagram A here. The mean and the median and the mode are all the same. In B, we have the bimodal with two different modes, and the median and the median are the same in both of these. They're right in the middle. And then in diagram C, which is really weird, every score is the same. So the mean and the median are the same, and there is no mode because all the scores are the same. Now, the graphs at the bottom you need to really pay attention to, because in those we have negatively and positively skewed distributions. So a skewed distribution is one that's nowhere close to symmetrical, as these are not close to symmetrical. And in diagram A at the bottom of the screen there, you see what we call a positively skewed distribution. And it has a long tail on the right or the positive end. And in these, the mean is going to be higher than the median. That is a positively skewed distribution, where more of the scores are toward the negative end or toward the low end. In diagram B, more scores, like a test where more people made a high grade, that is negatively skewed. And that seems backwards to me. It seems like that when more of the grades are higher, that would be a positively skewed distribution, but that's not the way it's named. So the one where most of the grades are higher, like in diagram B, that is a negatively skewed distribution. And that one, the median will be higher than the mean, and the mode will be the highest. Okay, now that we've talked about mean, median, and mode, those are our measures of central tendency, and those are pretty easy concepts. If you need to review any of that, pause the video and look in the book and read a little bit further on those. I'm kind of hitting the high points here. Next, we're going to talk about variability. And so how much do scores vary? Are they all close to the same, close to the middle, close to the mean? Or do we have scores that are extreme, that are very spread out and very far away from the middle? And that's what we talk about when we talk about variability. When we start talking about the normal curve in chapter 6, and we start talking about inferential statistics, we'll start talking about these tails of the curve that are way out away from the mean, being our extreme or our abnormal scores. And so variability is going to be play a big part in this later on.